So remember that our area is 1/2 ANS. Our perimeter is just the distance around, so it's 8 inches on one edge. They tell us it's a regular polygon, so they're all going to be 8. So the perimeter would be 8 times 5, or 5 times 8. And the perimeter is obviously important for some of these formulas we've been doing. Now for A, N, and S, I know the number of sides is 5. I know the side length is 8. I need to find little a. And it's one of the putsy things we have to do in this chapter, but again, that's why we're practicing it in the warm-up question, just so that you don't have to be nervous if that comes up. Hopefully we'll get a little bit better at it. Now this one doesn't give us as much information as if they gave us one of those two sides. This is the kind that we have to find that angle. Now remember, when I draw this little triangle, this would be 4 because that's half of that side length. But I need to find that top angle, and so I'm going to do 360 and divide by the number of sides. What is that, 72? So 72 degrees. Now that's not going to be this top angle, it's going to be half of that. So that's going to be 36 up there. So we're going to find little a using trig. And you can either reverse change your perspective, otherwise just set it up the way it is. And so hopefully that you're not struggling with doing these anymore. It's kind of becoming a little bit better. It's also reviewing our trig, which is good because that'll be on our exam at the end of the year, which is not that far off anymore. So we get 5.5 for little a, I believe. Or 5.51 if you went to another decimal place. Now, so if I want to find the a, I'm doing half of those, but again, I like leaving that previous answer in my calculator. So kind of what Kylie and I were talking about, she was like copying and pasting the previous answer. I just like hit n times, and then it just takes 5, I multiply by 8, and then I divide that by 2, and I get 110.1, and that'd be square inches. So our area and perimeter, again, hopefully that's becoming a little bit more automatic for you guys on regular polygons. Because when we first learned these were kind of the toughest ones we would have, is where we had to find that angle. I'm hoping now, like, these are starting to, like, we're starting to get good at them. So, again, a few more formulas, so thank goodness that we're going to have a chart for this test. But again, knowing how to use the formulas, because if I just gave you a sheet of formulas before we started this chapter, you probably wouldn't know what half these letters stood for. Maybe you could try to figure it out, but obviously we know a lot more than we did before. So, we're talking about pyramids and cones today. So, our regular pyramid, a regular pyramid has a regular polygon at the base. Now remember, a regular polygon is all equal sides and angles. So like a square would be an example of a regular polygon. I don't think I need to define the word pyramid. I think most of us know what a pyramid looks like. I mean, they're, like movies, cartoons, pyramids, like even little kids probably mostly know what a pyramid looks like. Now, but again, our bases can be things other than just a square. It could be a triangle, it could be a pentagon, it could be different shapes like that. Now the altitude is So I drew this, I had this drawn for you because this is a hard one to draw, and it's hard to draw that altitude down the center. So if you guys see it, like it's pointing at the line down the middle. So if you're picturing a pyramid and like picture like, you know, like adventure, like you know, like Indiana Jones type thing, which is now really old, is that if I would drop down through the middle of that pyramid, or I wanted to put like a support beam through the middle of my pyramid, that would be right down the center, and then it would land right in the middle of that shape, like the line on the shape on the bottom, the base. And it's always perpendicular to the base. So the altitude has an endpoint at the center of the base, and it's perpendicular to the base. So it's going to be dropped right down the center, through the middle, perfectly straight line. So again, if I hung like a string straight down through the center of the pyramid, it would go right to the center of that base. And so they have a little right angle drawn there for us. The other really important line is called the slant height. And it's, I think it kind of sounds like what it is. Slanted, you picture like that's like the side of the pyramid. The slant height is down the middle of one of the faces. It goes straight down. So if you were like sliding down the side of the pyramid, again, think adventure, like we're in Egypt, like you're sliding down the side of that pyramid, you go right down one of the main faces. And they use kind of a weird symbol for that. They use a cursive L, lowercase l, so they use, like, it looks like that. So that's our slant height. Technically, it's like the height of the face. So that's straight down this side here. So kind of noticing what they're pointing out in the drawing. So it's a little bit more complex, a little harder to draw and kind of see what's going on there. Perpendicular to the base. So it's perpendicular to this base edge. And again, thankfully we don't have to memorize these, but all of them have similarities, so it's not going to feel brand new to you, I don't think. So our surface area. Now we still use the base, but then we're going to add 1/2 P times cursive L. And I'll remind you guys what everything stands for. So S is obviously surface area. And just a reminder, surface area is we're trying to cover the pyramid completely. Like, so we're trying to cover it in fabric or whatever it happens to be, surface area. Sorry. B is the area of the base, whatever that shape happens to be. Capital P is the perimeter of the base. And then that L is called the slant height. So typically the altitude is not the one that we'll use in the formula. So like straight through is not the one we'll use that slant height, so the slanted one. again, so the problem we're gonna do together, I consider to be like above average of difficulty. So just that you guys know, there's gonna be questions that they literally give you all these different pieces, or you're easily able to find the area of the base. They're gonna tell you the slant height. They're gonna give you that information. The one we're gonna do is, like I said, like maybe medium to difficult, because we have to do a little bit more work to figure it out. So stick with me, let me know if you have questions. So it says find the surface area of the regular pyramid. But if you guys notice, they tell me, like going through the center, they're telling me the altitude. That is not the slant height, so that is not L. So they have not given me that information. Now it's a regular pyramid. What does that mean our base is? Our base is gonna be a square. Since it has 4 sides, we know automatically that the only 4-sided regular shape is a square, because it's all equal sides and angles. So that we know the base has to be a square. So again, our formula is base plus, 1/2 PL. So our base is our square, so we're doing the area of the base. Well, if it's 8 here, it has to be 8 here as well, so 8 times 8. So our area of our base is 64. Because it's base times height, right? Area of our square. And so when we make this chart for our test, we're probably going to put some of these formulas on there. Hopefully square, you wouldn't have to write that down, but like the area of a triangle, area of a trapezoid we haven't done a ton, but like area of regular polygons. So that's going to be important. So we found B. Now we're going to find P, which is the perimeter of the base. And that's just the distance around, so it's going to be 8 plus 8 plus 8 plus 8. So 8 times 4, so that's going to be 32. So we found P. Now we need to find the slant height. So again, what that is if you can picture going down this side here, but they don't tell me that. They tell me straight through the middle. So what we're gonna do, and it seems kind of weird, so out of this 3-dimensional pyramid, we're gonna make a little right triangle. Does that make sense? So we're using the slant height with the altitude and then going across the bottom. So the altitude is the perpendicular one. We're looking for this one. Now think about it a little bit here. If this is at the center, yeah, this little line across the bottom is just going to be in the center, so if it's 8 all the way across, it's just going to be 4 halfway. Okay? So finding slant height is not super difficult, but at the same time, like not just a gimme in this case. So we're going to find that by doing Pythagorean theorem. And I believe we get like 10.77. Okay. And now we're going to put it all back into our formula. So base plus half, 32 times 10.77. And I might go backwards with that. So I might leave that 10.77 in my calculator, multiply it by 32, take half of it, add 64, just to be a little bit more accurate and not like rounding off as much. Brains, S plus, S equals. And I got like 236.3. And this will be feet squared. Again, this is our surface area. This is how much space would be covering our pyramid. And again, I think just looking quickly in our homework, a lot of these, they tell you that slant height, so they're giving you that information. Probably the tougher part maybe is finding that area of the base. So just a heads up there. All right, our next one we're going to talk about is a cone. And again, like I said, a pyramid's probably one, like even if I went down to kindergarten, they would know what a pyramid looked like. If I went down to kindergarten, they definitely know what a cone would look like, I'd hope. Otherwise, they've lived a sheltered, non-ice cream filled life. So our cone, it's important to point out that the base of our cone is a circle. So we're going to talk about cones that have circular bases rather than being like, I don't know, like a
Waffle cones.
waffle cones maybe have, yeah. So
Those are circular bases.
So, our base is a circle. I don't love waffle cones, but I love them, like I like the pizzerias because they're like fresh, like he makes them like there.
Here's a place we go to.
It's how
You can see
Oh, that's nice. Yeah, it's yummy. Alright, so our cone, our base is the circle. And the good news is a lot of the same things are the case here. So there's an altitude going through the center. There's also a slant height, again, sliding down the side of our cone. And then the base, and so we're going to be working with cones, like pretty straightforward here. Again, the slant height is going to be that it'll make a perpendicular triangle with our altitude. Okay? So, getting into our formula right away. Now, technically, I would say it's the perimeter of the base or the circumference divided in half, but I'm going to skip over that because I just feel like that's kind of silly because let me just explain that real quick. So I'll write out what it really should be because if we use the, maybe I'll write it here. So if we use the surface area of the pyramid to help us. For our surface area of our cone, we should do base plus 1/2 the perimeter, which would be the circumference, times the L. But, and don't do this, because I'm going to show you kind of the shortcut here. 1/2 the circumference is 2 pi r. Well, now these 2's just cancel. So that seems silly to write it out that way. So I'm going to skip over writing it this way. I'm going to go right down to this one. So kind of just trying to tell you where that kind of comes from. So if you ever look it up and the formula uses the circumference, I'm going to just get rid of those 2's right away. So I'm going to do pi r times L. So that's kind of where it comes from. So obviously our S is our surface area. I'm not going to write that out again. The base is the area of the base. And now since it's a circle, because it's a cone, that's going to be pi r squared. Obviously r is our radius. Pi is pi. Remember that the diameter divided by 2 is our radius, so if they give you the diameter. And then L is that slant height. So again, we'll finish up with what I consider to be a medium to difficult cone problem, and then you guys will have time to work on this. So it says find the surface area of our cone. Now this one, they don't give us the radius, which is not too tough to find, but they also don't give us the slant height. So we have those 2 we're going to have to find. So that's why I call this medium to difficult. So using our formula, so our area of the base, but I'm going to first talk about R. So the 12 they're telling us is supposed to be all the way across. So D is 12, which means R is just going to be 6. So we found our radius already. But again, they're telling us the altitude, we need to find that slant height. Now remember, this little right triangle here, the whole way across is 12, so the halfway would be 6. So again, we'll find our slant height. So again, I get my L, and I know L, I know R, I know B, or I can find B, so I guess let's do that. So B is pi r squared. Now careful, R is 6, it is not 12. And 6 squared is not 12. So I think I found everything. So I have my B here, plus pi, my R is 6, my L is 18.97. And again, we have to do that all in our calculator. And depending on where you rounded, how much you rounded off, I got like 470.7, and that'll be centimeters squared. You might have gotten like a little bit under, a little bit over, 6, 7, or, but that I would just go with 7. Okay. So our homework is listed there, not super long. I believe it's 7 questions. And again, that'll be due on